believe it or not, there's still some humans that don't have smartphones. Okay, admittedly, they're either very poor or they're very, very young or very, very old. But still, that means that the average person with a mobile device is spending more than 2,000 hours looking at it. 2,000 hours is 40 hours a week. So we're all like have an extra full-time job using mobile devices. It's an amazing number. And the one that interests me last year is last year was the first time that more than half of software initiatives in enterprise companies use mobile. So this has driven a huge take-up of JavaScript. And we've seen JavaScript use jump over 66% over the last 18 months. And of course, it's not just JavaScript, right? It's React, it's Angular, it's all the frameworks around JavaScript because of those interfaces. Because when you're actually doing mobile development, it's kind of 3 steps in here. The first is pick a platform. Now, normally when I say mobile development, people think Apple or Android, right? Swift. Anybody here ever try to write something in Objective-C? You poor, poor people. Did you try writing a second thing in Objective-C? Wow. Okay. And so there are uses for that, especially if you're writing games or other things that need really low level. Most applications, though, today are going to be in Swift. Well, the Amazon view of this is these are also mobile devices. A laptop is a mobile device. A tablet is a mobile device. So when we think mobile, we're including all of the user interfaces. So JavaScript, and if you don't recognize the symbol on the lower right, that's a symbol for React. And then you set up a cloud service, so a mobile hub, and then you connect your app. So the service we do for that is called AWS Amplify, and that's our service for mobile development. This is kind of crazy easy to use. I remember writing mobile apps 10 years ago, and it was a lot of work. To initialize your app, you do AWS Mobile Init. To enable user sign-on, you do AWS Mobile User Sign-In Enable. That's it. And that does all of the background work to set up OAuth to allow you to have sign-in through a registration system of your own, or connect to Ping or Ookla or Google or Facebook or Amazon. Supports user sign-on, is doing all that through Cognito. It supports analytics, doing all that through Pinpoint. It automatically sets up connections to DynamoDB and to S3 and to Lambdas and API Gateway. So all of the work for the stuff that you used to have to do is kind of automatically done for you. I almost got angry when I first ran into this because, I used to spend like weeks doing this work. And now it takes, 3 minutes, maybe less. There's libraries in there. There's a JavaScript library. There's categories for auth and analytics and stuff you'd expect. There's React native extensions. And then, of course, it's all been open sourced. So we have all of these tools to go ahead and write this stuff. And then, in my app, I need to connect my app. So it's usually about 2 lines of code. So it's lines 6 and 7 on there. Amplify, configure AWS exports, and set your language, in this case, French. If I then want to have a German version, 1 more line of code. If I want an English version, 1 more line of code. So all these things set up your environment. I've got everything I need to do. When I'm ready to deploy my object, I do AWS Mobile. AWS Mobile Publish. If I want a test version, AWS Mobile Publish -- test. And then can see it all on this console, which will let me see what's actually out there and just click to integrate backend features or do a performance test or whatever. Okay, that makes mobile development crazy easy. It only leaves one little problem, data. That's kind of a big problem. There's a lot of problems with data. Problem number 1, data requirements vary across devices and they become harder when users share data, right? I'm going to have different ways I want to deal with data in different interfaces. I'll give a simple e-commerce example. If I go to Amazon or another e-commerce site on my laptop and I look for books, how many choices do I really want to see on my screen? 5, 6, 7, 10? That's okay. What if I'm using my Android device? There's not really room on here to see 10 books. So I need to change it to a smaller number, 4 or 5. What if I'm using Alexa and I'm voice shopping? I want Alexa to rattle off 10 choices. I have to even be more focused and usually do 2 or 3. So I have different data needs in different interfaces. And users want instant access. But they also want to use their apps where there's low or no connectivity. Are you ever someplace where you don't have good connectivity? Okay, if you're not nodding your head, then you're lying. Of course you are. I will admit, as an American, I'm used to having fairly inconsistent connectivity when I'm in the United States. And I come here and say, great, Germany, I get great connectivity everywhere. Yeah, sort of. But last week when I got on the train in Cologne and rode the train to Munich, sometimes I had good connectivity. Sometimes I had no connectivity. Sometimes I had bad connectivity. We're all on trains sometimes. We're all in elevators and lifts sometimes. We're all in places that this isn't going to work well. There's the other issue that comes up. When I'm using a laptop or a desktop, I'm plugged into power. When I'm using a mobile device, if you're writing for mobile devices, you need to be the steward of your customer's battery. Because if you write a really awesome application that drains the battery in 5 minutes, you haven't really done them a good job. What drains the battery? Louder. Data transfer, right. Because if your smart device is like most, it's got 4 antennas in it, right? It's got a Wi-Fi antenna, it's got a mobile network antenna, it's got a Bluetooth antenna, it's got a GPS antenna. Unless you're in the military, the GPS is read-only. I hope your GPS is read-only. But all the others are read-write. And every time you move data across them, they use power. Bluetooth, in theory, is low power, but most Bluetooth apps are so chatty, they end up draining a huge amount of power. So how do you minimize the drain on the battery? Move data less. So the key to that is moving from accessing data on demand to having a local data cache that then synchronizes when changes occur, and using the power of caching. So our way to do that is AppSync. So AppSync is an Amazon service that was introduced last year at reInvent, so about 6 months ago. And it's designed for real-time collaborative apps with an offline-first model, which means AppSync mostly uses lightweight database on the mobile device and synchronizes it with the back end when needed, so that whenever the application is looking for data, it's looking locally. So even if you're offline, I can still use the application. And then when it gets online, it'll synchronize as needed. And it gets only the data that you need. This is another big deal of designing this, so that if I have a 100 kilobyte database locally, and I only change 2 rows, I don't move 100 kilobytes. I only move the 2 rows. So it actually uses an open standard called GraphQL in order to minimize the data that's moving. And it can do this from multiple data sources, and it has good security controls. So what do we actually do with this stuff? I do a lot of collaboration apps, dashboards, leaderboards, social media chat, geographic applications, storing local geo information, complex data structures. And being able to store this and replicate gives me the ability to do data locally. Now, it's going to store it all locally, generally in JSON. So I build this stuff really easily by just creating my schema, connecting the data sources, and letting AppSync take care of it. And I'm able to get to rich data. So I'm going to get usually JSON data that looks like this. And when a client requests just what it needs, it'll get just what it needs. So when things change on the backend database, it'll synchronize out as needed. When things change on the local database, it'll synchronize with the backend. Okay, easy. Except, of course, for now, how do I deal with the backend? Because how many users can I have on one mobile app? How many? Millions. Tens of millions. Maybe hundreds of millions. So how big does the backend database need to be? Okay? If you're an architect, you know the answer to that question. It depends. So this leads to a little discussion about Dynamo. So initially, we created Dynamo at Amazon because the databases available to us were not doing what we needed them to do. Dynamo was initially created at Amazon around 2004 because we were growing too fast and we were outgrowing the capability of MySQL or any relational database to cover our needs. They didn't scale high enough. They weren't fast enough. We also had the problem with schema management because whenever we wanted to add a new product category, we had to change the schema of our database. Right? We're selling books. Now I want to sell radios. Well, radios have different information than books, so I need a new schema. We couldn't add schemas fast enough. So we went and created a new database that the schema was not controlled by the database, by the application. We called it Dynamo. This paper was published 11 years ago. The same month, October 2007, Google published a similar paper about big data. So the trade press saw that Dynamo and big data and said, well, neither of these use SQL, so we're going to call these NoSQL. So at Amazon, we hated the term NoSQL, but we're kind of stuck with it. Now, we developed this and used it only internally. 2007 was about the time that Amazon Web Services was launching, so we didn't make it a web service initially. And there was a lot of interest in this. So like Facebook came to us and said, hey, could you sell us this database? We said, yeah, not really. It's not designed to be sold. And they said, no problem. We'll write our own version. So they read the paper and they wrote their own version. They called it Cassandra. So if you ever use Cassandra and you say this is similar to Dynamo, there's a reason for that. Meanwhile, coming from another direction, there were document management databases like MongoDB that came up, became part of this NoSQL. And one of my favorites, because I actually worked on this in the early days, was a project at CERN in Geneva, the Center for Nuclear Research, because they had the problem that people would give them like huge amounts of money for physics devices, but they only had like leftover computers. So they needed a database that would run on unreliable computers, so they called their database Collection of Unreliable Crap Hardware, Couch. And this is where CouchDB came from. Now officially, when they launched it, they changed that to Collection of Unreliable Commodity Hardware. But if you talk to any of the Couch originators, they'll tell you, yeah, it was crap. But it worked. It let them have unreliable computers, but still have reliable database by doing replication, other pieces. And there's also Couchbase and other things in that space. So we've got all of this stuff in this NoSQL revolution, which is all about scalability and performance. So when I look across the world of NoSQL, I have key value, I have graph, I have document, and I have column family databases. Dynamo is a key value database. So 2007, we published the paper. 2009, we started showing the details of what we did, and we launched it as a service in January 2012. So since then, it's been available to customers as well as to internal Amazon use. And there's a few things about this database that make it really suitable to mobile development and other high-performance development. One is, it is extremely highly available. One of the Amazon requirements is a database that never goes down. That means no planned outage and no unplanned outage. So we achieve that by Dynamo always writes everything into 3 different availability zones. So there's 3 copies of all data. Whenever you do now that means it's eventually consistent, because I write it in one availability zone, say, okay, I'm written, and eventually copy it to the other 2. So whenever you read from Dynamo, you have 2 choices. You can do a standard read. Standard read will just grab the first availability zone it sees, or a highly consistent read. Highly consistent read will read all 3 availability zones and give you the newest one. So a highly consistent read has twice the cost of a standard read. So you can decide which sort of read you want to do when you read the data. And that way I can never go down, because whenever we're doing upgrades or other things, it can happen rolling across those availability zones. Consistent single-digit millisecond latency. This is really important. Every query should take less than 4 milliseconds, no matter how big the database becomes. And there is really little practical limit on how big I can make this. We have individual customers with more than a petabyte in a single table. Anybody here have a Samsung phone? Okay. Samsung mobile backend is one of those customers. So the Samsung, as you might suspect, they run that in the Korea region, and they run a backup copy or a synchronized copy. It was called a global table in the Dublin region. So if you're using the Samsung functions, they're probably going through AWS and hitting Dublin. But it's a single table that they put all of the Samsung Pay, Samsung Mobile, Samsung functions in. You have other customers that get really big, and you still get milliseconds, 2 to 4 milliseconds. This is a key difference from relational databases. The bigger they get, the slower they get. Dynamo's explicitly, the bigger you get, it doesn't matter. It's fully managed. So all those things like backup and updates and so on, they just happen. It's secure, and it's serverless. More about this later. You don't pick an instance size. It can automatically get bigger or smaller within the limits that you set it. So you often see usage patterns like this, where you see big spikes. Sometimes they're predictable, sometimes they're not predictable. This is what we're trying to deal with Dynamo. If you're writing mobile apps, you'll probably get these kind of spikes. Stuff happens in the world. All right, so what does Dynamo look like? Well, the basic function Dynamo is a table. You define a Dynamo table. You define a Dynamo table in a region. So you can have a table in Frankfurt, or a table in Dublin, or a table in Virginia, or whatever. And then inside that table, I'll have items, kind of like a row. And then inside those items, I'm going to have attributes. Now, one attribute is the partition key. That one is mandatory, because that one is used not only as part of the data set, but to create partitions to manage this. And this is how I'm able to grow and spread across multiple systems. So I have a partition key. You optionally can have a sort key. If you do choose a sort key, that lets you do some faster queries on the sort key, but it also has to be in every item. All of the other attributes don't need to be in any, can be there or not. So notice the first item has an A3 and an A4. The second item only has the partition and the sort key. Third item has different ones. Fourth item has different ones. You can have the information you need to have. So back to my earlier example, one of these can be a shoe, and another one can be a radio, and another one can be a book. So I can have different pieces of information, and they can coexist in the table. We use this a lot in microservice design, partly because I can have many different microservices coexisting. So do I have one table for all my microservices or a different table for each microservice? It doesn't matter in Dynamo. How would you rather manage it? You can have a local secondary index created at creation to make sorting faster, but usually people use a global secondary index, and like you're used to in databases, it's an index. So a GSI technically is another copy of the data, but in a different order. And the order is whatever you chose for the secondary index. So in this case, here's a secondary index on the top that has everything in it. There's one in the middle that includes just the A2, and then one at the bottom that's just the keys. Secondary index will always have the keys, but it could be other orders. So this, like any index, lets me do queries faster. We keep the database simple. It only has a few data types. So the usual ones you'd expect: strings, numbers, binaries, booleans. And then in the table name has to be unique to your account and a region. And then I give it a number of reads and writes. And this is how many reads per second and writes per second. And to be very specific, we call that a read capacity unit and a write capacity unit. This is how you pay for Dynamo. So a read capacity unit is 1 read per second up to 4K, 4 kilobytes. So if I read a 100 kilobyte object, that's 25 RCU. If I read a 1 kilobyte object, it's 1 RCU. If I read a 1 byte object, it's 1 RCU. So each read is 1 per 4 kilobytes. Write works the same way, except write is per 1 kilobyte. So if I write a 1 kilobyte object, it's 1. If I write a 10 kilobyte object, it's 10. If I write a 1 byte object, it's 1. And then it will automatically shard this horizontally. It will create partitions. So each partition in DynamoDB can support 1,000 read per second and 1,000 write per second and 10 gigabytes. And whenever you get bigger than that, it automatically shards off another partition. So, wait a minute, 10 gigabytes. So does that mean that if I have a petabyte, I have, 100 million partitions? Yeah, it's okay. It's designed to handle that. So your table, you might have 1 partition, you might have 1,000 partitions. You don't pay for the partitions. You only pay for the WCU and the RCU. You pay for the writes and the reads. You also pay for the total space, but not for the number of partitions, just the space actually used. And then the stuff will get automatically sharded and spread by the partition key. So that's why the partition key is important. So again, if I have a partition and partition C gets too big and it needs more space, it'll split into a D and an E. And another piece is if I add more capacity, again, I can only handle 1,000 per. So if I had partitions A, B, and C, but I set it up to 6,000 read units, well, I can only handle 1,000 per partition, so it'll split me into 6, and so on. Again, all this happens underneath. Partitions will take care of themselves. And again, everything is written 3 times in 3 different availability zones. So when I look at that partition-wise, data is replicated by design. It'll go ahead and do a hash against the partition key, and then figure out what partition to put it into. So this is the stuff under the hood that you don't really have to care about inside the engine that lets it get to this high scalability while always maintaining high performance. Because when you're doing a query, it's actually querying every partition in parallel. So it's able to do, even if I have hundreds of millions of partitions. Now, here's what makes this really great for developing microservices or mobile apps: streams. Whenever I write something in the Dynamo, it's exposed as a stream. Every put, every time I change data, delete data, it's in a stream. It's an ordered stream. It goes in the stream once, and it goes in the stream by the timestamp it happened. And it's retained for 24 hours, and again, across 3 availability zones. So I have a durable, reliable stream of everything that just changed. And what can I do with that stream? I can do all sorts of stuff with that stream. I can feed that stream into Kinesis and feed it somewhere else. I can feed that stream into Firehose and send it to Redshift or Elasticsearch for analytics. I can have that stream kick off Lambdas that then do specific code pieces. Streams are an amazing way to program. If you've never dealt with streams before, this is a technology you should learn. If you have dealt with streams before, you're probably really annoying because you tell all your friends about streams and they wish you would stop. Because it really is an easy and a great way to program and a terrific model. Now, one other little trick in there that's usually important is a lot of the data you're going to save is ephemeral. It's session information, other stuff you don't want to keep. So by default, the time to live is infinite. It'll stay in Dynamo forever. But you can set a time to live, and then when it hits that time to live, it automatically deletes. And by the way, this is a way to save money, because if you delete it manually, you have to pay for a write unit. But if I delete with TTL, with time to live, then it just disappears. So go away for free and on its own. We also can do auto-scaling, because I don't really know with my mobile app how much capacity I need. So what you do is you set it to a fairly low number, 5, something like that. Turn on auto-scaling. Now, auto-scaling works on a 5-minute running average. So can you see how the blue line shows the need and the red line is showing how about every 5 minutes it's popping up? And then given the need, if I extend a little further to the right, you see it drop way down. So this lets me automatically scale, and you can set the limits to how high it can go or how low it can go so it doesn't scale outside your chosen range, because that will control how you get charged. And it's separate auto-scaling for read and for write, because usually reads are going to be more variable than writes. It depends on your application. I was dealing with one of our customers that deals in sporting goods. The day that Germany won the World Cup, there was a real big spike. That day, they sold 25 times more German gear than they ever had in any one day in their history. I find it amusing that nobody bought it until after they won. But there was this huge spike in that demand. Because they were using Dynamo, they can handle that. Now, sometimes I need even faster reads. That's the DynamoDB Accelerator. That's an optional service you can turn on that adds a caching layer. This will make Dynamo about 10 times faster for data that can be cached. So this will automatically cache everything that's coming into the database. And when you configure this, you are picking a certain amount of memory. That's how much memory it'll cache. If you pick larger memory sizes, it'll cost more, but also cache more memory. Things that are in memory, I'm going to be able to read, as I said, in between, instead of 2 to 4 milliseconds, 200 to 400 microseconds. So we'll be able to get these things done really quickly. The other interesting thing is if it's in the cache, you don't have to pay for an RCU, so it can save money. So I'll give a real-life example of that. One of our customers is a company that does weather information. Now, how often do you normally look at weather information? Once a day? Unless, yeah, something's happening, right? You know, Schneefall. You know, there's a storm coming, there's something, and then you start looking at it every minute. Or if you're like me, and you, or like I used to live in Texas. Every so often in Texas, you get, as we used to say in Texas, God trying to kill you. Because you get, you know, these typhoons and tornadoes and giant storms coming. And when that happens, the people in Texas on their smartphones are going, update, update, update. Now, they were using not a whole lot of write, because the incoming weather data is a pretty common stream. So their write was like 50 per second, 50 WCU. But their read was sometimes spiking up to 100,000 or 200,000 RCU because of all these people updating. Well, that's very cacheable data, isn't it? So when we turned on DAX, we changed their RCU from 1 to 200,000 to 1,000, which saved 99% of the cost. Now, admittedly, DAX costs something, so the total saving wasn't 99%, it was about 95%. But it's still able to save a lot of money and be faster. So if you have cacheable data, the great thing about this is you don't have to change the programming model at all. It looks just like Dynamo. You're just changing the endpoint from the Dynamo endpoint to the DAX endpoint. And that's what it reads. So it adds a lot of cache rapid capability with very little work. I'm a big fan of caching. The thing I don't like about caching is complexity. This gets rid of the complexity. Another trick we have is global tables. Now, when you first create a table, it's local or global. You can create a global table that's only in one region. But the reason, of course, to create a global table is then you can pick other regions and will automatically replicate. And it's an active table. You can write into any of the regions. Now, this makes the table bigger because it's adding timestamps. So the table will be about 40% larger than it would have been without global because I'm adding all these timestamps. You need 40% more WCU. But the advantage, of course, is now I have an active solution. Now, warning. What happens? So let's say I have it active in Frankfurt and Oregon. Well, when I write it in Frankfurt, it's going to show up in Oregon about 50 milliseconds later, because it just takes 40 milliseconds to get there. But what happens if I write it here and 5 milliseconds later somebody writes to the same item in Oregon? I get what's called a collision. So we've exposed all the tools you need to deal with collisions, but in your code, if collisions occur, you're going to have to decide, does the first one win? Does the last one win? Do we write them both with different keys? How do you deal with it? But still, we allow this to be active multi-region, and you can have any number of active regions in here. So this really gives us an ability to do large and global environments. And of course, we have global backup, and of course, we have server-side encryption, compliance, and avoiding code rewrite because we make sure that we never change the APIs. We had new APIs, but in the years that we've been selling this, we've never forced anybody to rewrite their code. So there's some stuff in there, if you look at it, it says this is deprecated. We'll still support it, but please don't write new code this way. There's a better way to do it. But we do keep that going and support it. So it gives me an environment to give me my full solution for mobile development. So when I put this all together, what do I have? I have tools that make it easy to write mobile code. They get rid of the undifferentiated heavy lifting. Get rid of all of that stuff that you have to do that doesn't really anybody care about, but is necessary. So I take care of authorization, take care of deployment, take care of deploying to multiple languages. All that stuff is built in. I have AppSync to give me a really powerful offline first design so that data is stored locally and only synchronizes the minimum data necessary to make the application work. And then I have DynamoDB to have a fully scalable key value store that allows me to work at any scale and allows me to rapidly change scale and only pay for what I'm actually using, as it will auto-scale up and down for what I want to use. I put all that together, I have a really effective way to deploy mobile applications. Sorry if I sound a little bit like a salesman now, but I'm excited about this. It's made it much easier to write these things. So I'll describe that a mobile application that I've helped develop, because back home in Oregon, I own some vineyards. And working with these kind of tools, we've been able to create mobile applications that combine with IoT that allow organic winemakers to get about 1.5 times the yield that we were able to get before, because we're actually able to understand the moisture and sunlight on a 1 meter basis. So if you know anything about wine grapes, they're like Goldilocks and the Three Bears. Too little water, bad grape. Too much water, bad grape. And the right amount of water changes over the harvest cycle. But by being able to monitor this way, we're able to get organic grapes at a much higher yield. And I wrote an application, just me, in about a day to do this, that a few years ago would have taken me weeks to write all this background stuff. And what's really great about it is I was able to deploy it, put it out, have people using it that day, and have it automatically scale to their usage. So I'm really excited about this and the things that we can do with it. So, do you have any questions about mobile development or Dynamo? If you do, raise your hand so Calvin can give you a microphone. And be warned, this is all going out live on the internet. So if you ask any questions, make them good ones. All right, who has a question? Oh, come on. They're questionless? Wow. All right.
Thank you very much. Yeah, very interesting talk. I just recently started with mobile development, so basically my question could be totally bullshit. But I get started with Fire.
My answer could be totally bullshit too. So
That's cool. That's cool. But what I was wondering, I started using Firebase and I liked it because of its simplicity. Because you can really just boom, there you have everything. And I was wondering if you can reflect how to get similar services with AWS components, or how they both compete or not.
So Firebase, first of all, is a great partner. And you can certainly run Firebase on AWS, and many of our customers do. But to a large degree, the interesting things about Firebase are rapid integration and offline first data storage, which is what we do with AWS Amplify and AWS AppSync. So it's not compatible with Firebase. I can't just copy the code over, but I get similar functionality. So the real question is, would you rather have Amazon manage the services for you? Or would you rather run Firebase where you have to manage the service? But Firebase is awesome, and it's a great way to write this stuff too. So I won't say bad things about our partners. All right, who else has a question? Wow, you must be ready for lunch. Okay, so if you have a question that you don't want to ask in front of the big room and get it live on the internet, then you can feel free to come up here and ask me that question. I'll be hanging around. I would ask you to go visit our wonderful sponsors, including Intel and Reply, as well as Unbelievable Machine and All Cloud, who are here, who can help you with these things. And other than that, get out there and do interesting things on the internet. Thank you for your time.